everybody. So today we don't have a live Zoom class, so I'm gonna have a lesson. You can watch whenever it's convenient for you. Um, Yesterday we were talking about factoring quadratics. Specifically, we talked about factoring quadratics where the first value, the a, was 1. And today we're going to go into factoring quadratics a little more in depth in terms of factoring quadratics where a is something other than 1. So we have some number in front of the x squared term. So where we left off yesterday was with this slide. So we talked about distributing those two binomials to each other, and we ended up with this expression. You had some practice doing distributing polynomials or distributing binomials during the homework yesterday, so hopefully you got a chance to do that. So let's move on. So here we're going to practice factoring expressions that are quadratic. They have an x squared, right? And a is something other than 1. So I'm going to over here list out a couple steps. So the first thing we want to do is we want to find two values that multiply to give us AC and add to give us B. So find values that multiply to AC and add to B. Now, let me tell you what I mean by those letters, right? So when you have a quadratic, it's of the form ax squared plus bx plus c, where a, b, and c are just constant terms, they're just numbers. So we want to find two things that multiply to give us a times c, which in this case is 6, and add to give us -7. Now, one thing to keep track of is the signs on these. So as you can see, 6 is positive and the 7 is negative. And so that means that when two things multiply to give you a positive, either they're both positive or they're both negative. And hopefully you can see here, they both have to be negative because they add up to a negative number. So if we check this, this will be -1 times -6 is +6. -1 plus -6 is -7. So we have those two values. Now the second step is what I call split the middle. This whole thing is called the English method, and this is a method used for solving any factorable quadratic. In this case, just factoring any factorable quadratic. And so what I mean by split the middle is I'm going to take the original expression, and this middle term I'm going to split into my two numbers that I just had. So I'm going to split up that number into those two. Now it actually doesn't matter the order you put them in, so I could say -6x and -1x, it doesn't really matter. And then our third step, we're going to factor by grouping. And so in that case, what we're going to do is we're going to take the first two terms and we're going to make them a group. And we're going to factor that group. We're going to take the second two terms, we're going to make those a group and factor that group. These are added together, actually. So this first set of terms, so the 2x squared minus 1x, there's no number that I can divide both 2 and 1 by that I could like take out besides just 1. So I'm going to take an x out front. And so when I divide each of those terms by x, I'm left with 2x and then -1. Next, if I look at the second group, I have a 6 and I have a 3. And so both of those are divisible by 3. So I'm actually going to factor out a -3 and end up with 2x -1. Now notice I factored a negative value out. So the +3 divided by -3 became a -1. If that's tricky, that's just an area that's a little bit tricky. So when you factor out a negative value from a positive, that becomes negative. Okay, and then our last step, let me actually change color here. Our last step is factor into binomials. So what I mean by that is I'm going to take this. If you've done this method correctly, you should have two binomials that are the same as the factors. So we're going to factor out that binomial. That becomes our first factor. And when we factor that out, we're left with x minus 3. So that is the factorization of that expression. Now, I want to point some things out. So this may seem like a lot, and it is. Even students that are in pre-calc sometimes struggle with this factoring, especially when a is not 1. So that's the reason I have the steps here. I'd reference back to those as you do your assignment for today. We're going to do more practice, and as you see more practice, hopefully these steps become a little clearer. All right, so I was having some technical difficulties. We will see if this works. Okay, so we left off with this previous example. I'm going to do another example. I'm going to stitch these videos together so this will seem like it's just right away. So we have this 3n squared plus 14n minus 5. And if we look back at that first step, again, we're finding values that multiply to give us AC and add to give us B. So here, A times C gives us negative 15. So 3 times negative 5, negative 15. And these add to give us 14. I also realized when I rewatched my video, I numbered these wrong. So there's 4 steps, not 5. And then if we look, we have this 15 is negative and this 14 is positive. Now, whenever we multiply things, we get a negative number. We're multiplying two numbers together. One has to be negative and one has to be positive. So that tells us that one of our values is negative and one is positive. And here, the negative value is 1 and the positive value is 15. So negative 1 times 15 is negative 15, and negative 1 plus 15 is positive 14. Then our second step, again, we're rewriting our quadratic, but we're splitting the middle term, the linear term, into two linear terms. So we're splitting 14n into negative 1n and positive 15n. All right, so there's our second step. Now our third step is factoring by grouping. So we're going to group this polynomial into two kind of binomials here. And so if I look at that first group, I would say, what can I divide 3n squared and negative 1n by? And there's no number that I can divide those coefficients by, but I can take an n out of each term. So I'm going to factor an n out of each of those terms. And I end up with 3n minus 1. Then I look at the second group. So the second group is 15n minus 5. Well, 15 and negative 5 are divisible by 5. So I'm going to factor out a 5. And when I divide 15n by 5, I get 3n. When I divide 5 by 5, I get 1. So there's my factoring by grouping. Then the last step says factor into binomials. So my first binomial is this 3n minus 1. If I factor that out of each of those, I get n plus 5. And so now I factored that quadratic. That's the factorization of that quadratic. I'm not going to do the third example right now. If you want to do that for more practice, feel free, but you will have some practice on your assignment for today. All right, next we're going to talk about some special quadratic expressions. The first one is called the difference of two squares. We're looking at perfect squares that are subtracted. So the pattern here is a squared minus b squared. That always factors into a plus b times a minus b. Those are quantities in parentheses. So the example, we have 4x squared minus 9. 4x squared is a perfect square, and 9 is a perfect square, meaning there's some integer value that I can multiply by itself to get those. So my a is 2x, and my b is 3. And so then you can see you have a plus b, the quantity of that, times the quantity of a minus b. All right, so let's look at using that down on an example, and we'll come back to the rest of that in a second. So here we have 4x squared minus 25. 4 is a perfect square, 25 is a perfect square. So you can see that a is going to be 2x, because the quantity 2x squared is 4x squared, which is what we have here. And then our b term is 5. And it's a difference of two squares. So from the previous slide, the pattern, actually let me switch that down a little bit just so we have room for other problem in a minute. So the pattern is a squared minus b squared factors into a plus b and a minus b. So here I could say this is going to factor into 2x minus, or plus 5, doesn't really matter if it's minus or plus first, and that's equal to 0. Now, this particular slide, the previous slide we're just factoring. This slide we're solving, so we need to say x is equal to whatever our two solutions are, our two roots. So this first one, if I was solving for that, I'd say, okay, subtract 5 from both sides, divide by 2. X would need to be negative 5 halves for that first binomial to be 0. For the second binomial to be 0, I would add 5 to both sides, divide by 2, and I would get positive 5 halves. So those are my two solutions. I've now solved that quadratic. Hello again. There is a second way to do this problem, which is if you have perfect squares like this is, and you don't have that middle term, which you wouldn't in difference of perfect squares, I could solve this by adding 25 to both sides, and then divide by 4, divide by 4. I get 25 over 4, and then I can simply take the square root of both sides. So the difference of squares has this pattern to it. And so if you recognize things or the difference of squares, if you start to see that pattern, you can say, oh, well, it's factored like this, and this is the solution. It's fairly easy to start to see. But you can also do it this way, where you simply get the x squared term by itself and then take the square root of both sides. Now, remember that when you take the square root, you get a positive version and a negative version. So all quadratics have two solutions. Sometimes those solutions are imaginary, which we will get to when we do the quadratic formula tomorrow and Thursday. So I know this is going to move kind of fast. All right. So now to this next kind of special quadratic expression case. And I'm going to work from right to left here because there are some things I want to point out. A common mistake people make when they see a binomial squared, which is going to end up being a quadratic, right, is they say, oh, well, I'll just distribute the square in there and I'll get x squared plus 9. That is not correct. That is a very common mistake. When you are squaring a binomial, that means you're multiplying it by itself. That's what squaring something means. So we're going to have x plus 3 times x plus 3, and then you're going to multiply those out if you didn't have this pattern. So from yesterday, the first terms multiplied together, the outside terms, the inside terms, and the last terms. So we get that. Now notice when I do those outside and inside terms, I get a 3x and a 3x. I get two of those. So that's where this pattern comes from. We get, right, so you have 2x times 3's. And then you have your first term squared, the x squared, and then your last term squared, which is the 9. So that ends up being x squared plus 6x plus 9. And the actual pattern goes, again, it's the first term squared plus 2 times the product of the terms plus the last term squared. A lot of people forget that 2 times the product in the middle because they think you can distribute an exponent, which you cannot. The second one of those is just if you have subtraction instead of addition, but it's very much the same pattern. Okay. So we're going to do 2 last practice problems. We're going to hope I don't have to record this video for a 4th time. And I want to remind you as we do these practice problems, we need to have our quadratics in standard form. So that means that they have to be equal to 0, typically. If we're solving these for factoring or a quadratic formula, these should be in standard form. Now this first one, so we have x squared plus 3x, we'll have minus 18 equals 0. This first one, there's just a 1 in front of the x squared if you think about it that way, or there's no number shown there. So we can do this like we did the ones yesterday. We're finding 2 terms that multiply to give us a times c, which in this case is negative 18, and add to give us b, which is 3. Now, like I mentioned before, when you have two things that multiply to give you a negative value, one of those has to be negative and the other is positive. So I could think now about what are my factors of 18. I have 1 times 18, 2 times 9, 6 times 3. And we can see here that we're going to have 6 and 3 because they're 3 apart. So here our negative value is going to be 3, and our positive value is 6, because negative 3 times 6 is negative 18, negative 3 plus 6 is 3. And then because our x squared just has a 1 in front, there's no number in front, we can simply say we're going to factor this as x minus 3 and x plus 6. Now, one thing I want to point out on your assignment yesterday, some of you said now, okay, well, x has got to be negative 3, but that's not the case. We don't copy those numbers down as our solutions. When we're solving, we say, what value of x makes that first binomial 0? And the value of x that makes that 0 is 3, because obviously 3 minus 3 is 0. The second value is the value that makes the second binomial 0, and that would be negative 6. So it's kind of the opposite of the numbers that you see. There's one thing to keep in mind. Now this next one, to get it into standard form, we're going to add 15 to both sides. Just put a little plus 15 on both sides. And in Algebra 1, hopefully you guys don't do this anymore, but sometimes people are saying, oh, well, those cancel out, so there's nothing there. We just say, like, we get rid of the equals and everything. Don't forget to put equals 0. That is what makes that an equation, makes it solvable. If we don't have the equals, we have an expression at that point. Now, these numbers look pretty big, and we're like, you could do it, but do you want to do it because they're kind of big? So you want to see if you could factor something out first before we start doing the rest of the steps. And here, I can see all those are divisible by 3, right? 3 is divisible by 3, 6 is, 9 is, 6 is, 15 is. A trick that I learned to see if things are divisible by 3 that I learned in 3rd grade and I still use is you can add the digits of a number together. And if the sum of those digits is divisible by 3, then the number itself is divisible by 3. So for example, 9 plus 6 is 15. 15 is divisible by 3, therefore 96 is divisible by 3. And that works with numbers that have more digits. So you can kind of check if numbers are divisible by 3 pretty easy. So I'm going to go through and divide everything by 3. So 36 divided by 3 is 12. 96 divisible by 3, or divided by 3, pardon me, is 32. And 15 divided by 3 is 5. And 0 divided by 3 is just 0. So I've simplified things a little bit. I haven't actually gotten to the factoring part. To go back to our steps, our first step is to find values that multiply to give us AC and add to give us. Back to the steps that we did before. So the first step was to look at finding values that multiply to give us AC and add to give us B. So if we go back to our quadratic, that means I need to find two numbers that multiply to give me 60. So that's from 12 times 5. And add to give me 32, which is my B value. So 60 has lots of factors, right? We can do 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. It's a lot. This one is 2 and 30. 2 times 30 is 60. 2 plus 30 is 32. Our next step, we are going to split the middle. So we're going to take that B term and split it into 2. So we get 12x squared plus 2x plus 30x plus 5. And that's still all equal to 0. Then my third step is to factor by grouping. So what that means is I'm going to take that quadratic and I'm going to put it into 2 groups. When I factor by grouping, I'm going to group the first 2 terms together and then the last 2 terms together. And so here I have the 12x squared plus 2x. And I want to say, what could I factor out of that group? So there's a 12 and a 2. That means I can factor out a 2. Those are both even numbers. Now, there's also an x squared with a 12, and there's an x with a 2, which means I can factor out an x from both of those. And when I factor those out, what I'm really doing is dividing those by 2x. So when I divide 12x squared by 2x, I get 6x. When I divide 2x by 2x, I get 1. Then I move on to my second group, and my second group has a 30x and a 5. Those are both divisible by 5. So I'm going to factor a 5 out. 30x divided by 5 is 6x. 5 divided by 5 is 1. And again, only the 30 has the x with it, so I can't factor an x out of that. Next, I'm going to do the fourth step, which is factor into binomials. So if we've done all this correctly, these two binomials should match. So that's my first factor. And then my second factor, when I've taken that out, is what's left. It's what I took out when I factored by grouping. So I get 2x plus 5 equals 0. Now, there were only those 4 steps when we were factoring, but now that we're solving, we have a fifth step, which is to solve using the zero product property. Now, again, what that means is when I have a whole bunch of things multiplied to give me 0, one of those things has to be 0. So in this case, either 6x plus 1 equals 0, or 2x plus 5 equals 0. Then we just solve these using our Algebra 1 skills. So I'm subtracting 1 from both sides, dividing by 6, and so my first possible solution is negative 1/6. And then next, I solve this. And my second solution is negative 5/2. Okay? Now, quadratics always have 2 roots, 2 solutions. In a couple of days, we're going to see this could be imaginary. We're going to solve with quadratic formula, but here we have those 2 solutions. Please let me know if you have questions. You can email me, post on the description.